So have you ever been in an elevator and if it's going up, you felt, I guess you felt something, and you've probably never described it like this, but have you felt yourself getting heavier? It's harder to stand. It's not going accelerating that fast enough, but if it was, you would seriously feel yourself getting heavier. Why is that? Because the net acceleration on you, or the downward acceleration on you, depending on for whatever reason, is increasing. It's not just gravity, but the motion of this elevator moving upwards also pushes you relatively down towards the elevator, right? It's kind of like if you're sitting in a car or sports car, and if someone slams the gas pedal, you'll jerk backwards, right? Why? Because even though you're moving forwards, you're not moving as fast enough with the same acceleration as the car is. So relatively in the car, you feel being pushed back. So let's do some math over here. With that, let's try to understand that better, a bit more mathematically using this problem. In the figure, a passenger of mass 72 kilograms, 0.2 kilograms, pretty standard, stands on a platform scale in an elevator cab. We are concerned with the scale readings when the cab is stationary and when it's moving up or down. So when it's stationary, it's going to read a normal thing. But if it's moving up or down, how will it change? Find a general solution for a scale reading, whatever the vertical motion of the cab. So assuming it's moving upward, whatever its motion, find out its this reading on the scale. How would that be affected? So let's try doing that. So this person is moving up with an acceleration. We don't know the acceleration, so we are trying to find a general equation. So let's say he's accelerating upwards with an acceleration of a, and that resultant force that's caused on him is equal to m times a, his mass times the acceleration, which is equal to the weight, which is over here known as Fg, and the upward force generated by the elevator onto the person. We'll call it Fe. And because they're in opposite direction, it's actually the difference. So Fe is upward, much like the acceleration, how it's upward, so that's why they're equal. And Fg I'm taking as negative because it's downward against the motion, right? Again, we're just assuming acceleration is upward, and we can change it later if it's actually downwards or not. We're trying to come up with a general equation. With that said, now what is this Fe? It's not only the force experienced by, it's not only the force experienced by the person due to the elevator. It's also the force experienced by the scale over here. Because over here, the only force acting between these two is, well, if it wasn't moving, it would be equal to his weight. And if this was moving, let's say upwards, the acceleration experienced by this person would also affect this thing, because he's accelerating because of the scale is actually pushing him up, and the scale is actually the one causing that acceleration, so to speak, because it's part of the elevator, or you can treat it as part of the elevator. That's the only way the human, or Mr. Einstein over here, Bertie, is in contact with the entire elevator, right? So that's equal to this. Even though it's a force caused by the elevator, it's actually equal to what's experienced by the scale. So we'll make that mind shift and also rearrange the equation. The force on the scale Fe is actually equal to the weight of Bertie minus ma. Actually plus, right? Sorry. Rearranging it, Fg plus ma, right? What is Fg? Fg is just mass times acceleration an acceleration due to gravity, which is g plus m times a. And let's actually solve mg. Let's figure out his weight. Actually, let's not do that, but let's do this. I think it'll make more sense. I'm taking m common and placing g in here. And we can do it the other way as well. I'm just only doing this way because it makes a lot more sense. And I'll tell you why. Right. So let's change our colors. And so mass is 72. G is 9.81 plus A, which is our true variable, is equal to the reading on the scale, FE we're calling it, which is equal to the force generated by the elevator onto the human, right? And this is our general expression. Let's say the person was going up was accelerating up with a force with an acceleration of 3 meters per second. We don't know the force 3 meters per second. Let's say that was A. So let's put that into the equation over here like that. Let's see what we get. And it's going to be 72.2, 9.8 plus 3 point, or just 3. And let's see what that comes out to be. About 924 or 92588 newtons. And that's the reading on the scale. That's the weight coming out to be, right? Plus, for perspective, let's figure out his actual weight, which is just 72.2 times 9.81. His actual weight is 708.3 newtons. That's his actual weight. And he seems to be 20-30%, 30%, 20-25% heavier. Somewhere along those lines, he's heavy. He's actually experiencing some of his own weight increased. Okay, even though he was on a good diet, Bertie here experienced a gain in weight. Why? Because the elevator is moving up, he's relatively feels being pushed down. And because he's pushed down more than his actual weight, the scale reading increases. And that makes sense logically, even before we start a calculation. We knew upward acceleration would lead to a higher scale reading. And we see exactly by how much. And the math also makes sense that way, right? Let's move on to part B. And we've kind of done it. So we've already moved on to part B. We've tried that. And we can try the other way. Let's say in this case now, Bertie here was moving down with an acceleration of minus 3 meters per second squared. Because it's downwards, I'm saying minus, but I didn't write down minus. So that'll be 72.2 times 9.8 minus 3, that acceleration. So 72 times 6.81 should do the trick. And his weight comes out to be 491. And if he's falling, if he's going down, he feels lighter. And that makes sense. Let's say this person was falling, Bertie was falling at an acceleration of 9.81. So if we put 9.81, this will come out to be 0, and this entire force reading will be 0. So the scale will read 0, and how will Bertie feel before he dies a horrible death? Is he'll experience complete weightlessness, 0 Gs.